Hello there, welcome back to the new lecture. So in this lecture we'll see the chill water pipe sizing by graphical methods. So after the end of this lecture you would be able to understand chill water pipe sizing by graphical methods. So let's start. So here I have taken the question here. Suppose this is our air cooled chiller. Okay, from the air cooled chiller we are supplying chill water to the AHU, FCU, FAHU cassette unit, and here the capacity of each equipment is given. Okay, this is our chill water return line. So the water which you are supplying from the chiller to the AHU, then from the AHU to the chiller, this is called as a closed loop piping system, or you can say evaporator side. So you know that for evaporator side, to convert the TR in GPM, we have a formula. 1 TR is equal to 2.4 GPM. So here you can see for 5 TR, when you calculate, convert into GPM, so 5 TR into 2.4, it is 12 GPM. Then 15 TR into 2.4, 36 GPM. Same way, here you will get 28.8 GPM. So finally, from the air cooled chiller, how much water we are supplying? Total 148.8 GPM water. Okay, in the return side also the water is same what you have got. So now once if you will get the water flow rate value, so you can start the chill water pipe sizing. So for that, here I am opening see the graph chart which we have taken from the ASHRAE handbook. Okay, so this graph is given here. So see the first one, this is friction loss for water in schedule 40 steel pipe for closed system. Okay, for closed system you have to use this graph, okay, for pipe sizing. And for open system, see, open system means the water which you are supplying from the chiller. In case of water cooled chiller, so you know that the water which we are supplying from the chiller condenser to cooling tower, then from the cooling tower to the chiller, so that is your open system. So for that you have to use this graph, okay, for pipe sizing. Okay, so right now we are talking about closed loop piping system, so I'm using this one, and the pipe is schedule 40 steel pipe. So this graph we have to use. So first try to understand. Here in the x direction you can see the friction loss value is given in feet of water per 100 feet of pipe length. See, in y direction or in vertical, here the flow value is given in GPM. See, 1.5 GPM, 2 GPM, 3, 4, 5, 10 GPM. Okay, so here vertical in y direction, the flow rate is given in gallon per minute. Okay, now you can see the vertical inclined line is represent as velocity in which unit? Feet per second, FPS. Okay, imperial unit. 1 feet per second, 1.5 feet per second. This line is 2 FPS line, 3 FPS line, 4 FPS line. Okay, so vertical inclined line or diagonal line, you can say, it is represent as a velocity. Same way here you can see the horizontal inclined line, this one. This line is represent as a diameter in inches, pipe size. Can you see? Half inch line, 3 by 4 inch line, 1 inch pipe size line, 1 by 4 inch pipe size line. Okay, now we'll see. So as I told you, first we'll start from this last section. For 12 GPM, I want to find out the pipe size. So with the help of pipe sizes software, already I have discussed. Now we'll see by using the graphical method how much pipe size is coming. So first, now what you have to do, here you have to see in the y axis, you have to see where is 12 GPM. Here I am just zoom in and let's see. So when you see in it, 12 GPM will comes near about, see now, 50, 10 or 15. So let's say I'm assuming 12 GPM is between 10 to 15. Okay, and velocity, how much velocity we have to maintain for chill water pipe size? Yes, any one of you? Generally I have told you, normally we have to maintain the velocity. In manual calculation also I have discussed the range. So the recommended velocity for chill water pipe size is 4 FPS. Okay, so where is the 4 FPS line? This one, can you see? This is our 4 fps line. Here it is written 4. So what you have to do, see, simple, just select and let's see. See, 12 GPM is here, suppose between 10 to 15. Okay, and draw one horizontal line like this, where when you see 4 fps line is where, just draw it up to here. Now see, both the flow and fps line velocity will intersect in this point. So based on this point you have to draw one horizontal inclined line. See, now you will get this size. So when you see here, for this line is 1 inch and this line is 1 by 4 inch pipe size. So which pipe size we have to select, 1 inch or 1 by 4 inch pipe size? So remember, here our main target, I have to do 4 fps we are maintaining. So if we increase the size, let's say if I am selecting 1 by 4 inch, so automatically the velocity will reduce. If you increase the diameter, so velocity will reduce. Better is to take 1 inch, because you can go up to 6 fps. Range is given in manual calculation, I have discussed. So recommended is better is to maintain 4 fps. Okay, so go for 1 inch pipe size. Okay, so here we'll write for 12 GPM, the size we have written 1 by 4 inch. Okay, so you can write that also. Here we have written 1 by 4 inch. Okay, we are considering this one because see, now 4 fps line and this flow are intersecting here, so you have to draw one horizontal inclined line. Based on that, select the when you reduce the size, you can also select 1 inch, but problem is what, if you are reducing the diameter, so it means for 4 fps, so if diameter will reduce, automatically what happen, the velocity will increase na. So that is why better is what na, always take the larger size. Okay, if suppose if your line is coming between both pipe size, so always go for the larger one, 1 by 4 inch. Okay, so that we have written here, you can see. Same way, next is 48 GPM or 36 GPM. For 36 GPM, if you want to see, so same here you have to open it, and where is 36 GPM? Between 40 to 30. So draw one horizontal line, a straight line. Okay, it will intersect where is the velocity line, 4 fps, this one. So see, the value is coming between 1 by 1.5 inch, then 2 inch. So you have to go for 2 inch size, correct? So in this way, generally you have to do the pipe sizing. So you can see here I have written 2 inch. Same way for 48 GPM, you will get 2.5 inch. For 28.8 GPM, 2 inch. For 76, from the graphical you will get. Finally, we have a 148.8 GPM. If I show you, see here we have got 4 inch. Same way in the graph also, if I show you 148. So near about 150, let's say. So just draw one line. See, both are intersecting in this point. So when you draw horizontal inclined line, see the pipe size 4 inch, correct? So in this way, generally we have to do the pipe sizing for closed loop piping system. Same way, let's say in your project, if you are using water cooled chiller, so you know that here we have an open loop piping system also. So for that, to convert it into flow, as I told you, you have to multiply by 3. 1 TR is equal to 3 GPM. So see, 90 GPM we have got. So for 90 GPM, how much pipe size? Here when you see 3 inch we have selected. Hot water supply and cold water return pipe size is 3 inch. From the graphical method, if you see, remember I have already explained you, for open loop piping system, just scroll down, you have to use this graph. Okay, see, this is for open system and our flow rate is 90 GPM. So where is 90? 90 will come between 80 to 100. Just this line, draw one horizontal line and see this line is intersecting where, and this is your velocity line, you can see. So both are intersecting here. So as per that, when you see the velocity, the size which we have to take is 3, because it is near about 3 inch only. So that is why here when you see, we have written 3 inch pipe size. Okay, so by using graphical method also, when you see now, the size is same little bit. Okay, maybe some difference are there, but it is same as per pipe sizer software or as per graphical method. So in this way, we have to do the chilled water pipe sizing for the closed loop system or for open loop piping system. So now the topics which we have covered in this session is what we have seen the chilled water pipe sizing by graphical method. Hope all of you enjoy the session. See you in next one.